Hello everyone, welcome back to my channel, which is Bundle Hub, and today we are going to look into Java 8 features basically, and mainly we are going to concentrate on the functional interfaces, Lambda expressions, and default methods of Java 8 features. So what is functional interface? An interface that contains exactly one abstract method is known as a functional interface. So any interface which contains only one abstract method gets converted and is called as a functional interface. So it can have any number of default or static methods, but can contain only one abstract method. So it should contain only one abstract method, whereas it can have n number of default and static methods. And it can also declare methods of object class. So the main criteria is that it should have only a single abstract method, but with any number of default methods, static methods, or methods of object class. So functional interface is also known as single abstract method interfaces or SAM interfaces. So this word directly implies that it has only one abstract method, so they are called as single abstract method interfaces. So Java provides an annotation at function interface, which is used to declare an interface as functional interface. So if you want to explicitly mark an interface to be a functional interface, then you can use this annotation. So once you use this annotation, all the rules that it should have only one abstract method. So all those validations will be automatically taken care by the compiler. That is, if you mark a interface as a functional interface and you try to declare one more abstract method in it, the compiler will throw you an error. And considering this example, you have an interface welcome in it, which is followed by the annotation function interface. So it directly depicts that this is a functional interface. And to provide an implementation for this abstract method in the functional interface, I'm going to create a class called functional interface example, which is going to implement the functional interface. So we already know that when a class is implementing an interface, so all the abstract methods available in that functional interface, we need to define it in our class. So we need to provide a definition for those abstract methods in our class. So this is how I'm going to provide a definition for this abstract method in this interface. So I'm going to create a class, implement that functional interface, and I'm going to provide the definition or the implementation of the abstract method in this class. And I'm going to create an object for this class, and I'm going to call the method. So this is how a simple interface concept works. So you create an interface and all those methods, you provide a definition in the extending class. That is the implementing class. So as I already mentioned, the functional interface can have object class methods. So let's see an example which includes object class methods in it. So this is a functional interface called welcome interface. It includes an abstract method called display, and it can contain any number of object class methods. So I've written three object class methods, which is hash code, toString, and equals inside this functional interface. So this is a valid functional interface, although it has many methods of the object class. And as I already mentioned, to provide an implementation or to provide a definition for this abstract method, we are going to create a class which is implementing that functional interface, and you're going to override that abstract method and provide the implementation for it here. And as similar to previous example, I'm going to create an object for this class, and I'm going to call that abstract method definition, which I have provided in this class, so that it is just going to print the string whatever I pass. So here is the output of it, where I just print the message welcome to Pandal Hub. So inheritance and functional interface. So how does the inheritance work in the functional interface? So a functional interface can extend another interface only when it does not have any abstract method. So for example, why do I say that is, if the other interface, if a functional interface is going to extend another interface and that interface is also going to contain an abstract method, then in that case, this functional interface which is extending that will include two functional interfaces, two abstract methods. I'm sorry, two abstract methods. So in the previous example, when this class is implementing this interface, so this interface, which includes an abstract method, we need to override it. It becomes a part of this class, which where we need to provide an implementation for that abstract class. Similarly, if this is not a class and we are going to implement a functional interface, we are going to extend one functional interface with another functional interface. So the abstract method available in this parent functional interface is going to become a part of this child functional interface. So in that case, the child functional interface is going to contain two abstract methods which will break the concept that it should have only one abstract method. So to maintain the functional interface concept, or to maintain the rules of that functional interface concept, to maintain that it should contain only one abstract method, we cannot implement or extend another interface which includes abstract methods. But it can contain default methods, or static methods, or methods of the object class. So that doesn't change the behavior of this functional interface. So here we have an example like the functional interface display. It is going to have a default method, and we are going to write a. So this is not a functional interface because we just have only the default method, but we don't have an abstract method. So it is just an interface. So here, going with the functional interface example, we have a functional interface demo, which is extending a normal interface display, and we're going to have an abstract method which is welcome. So to provide an implementation of this functional interface, we're going to create a class which is implementing the functional interface, and we're going to provide the definition for that abstract method here, which is the welcome method. And in the main method, I'm just going to create an object for this class, and I'm going to call the abstract method of that functional interface, and I'm going to call the default method of the parent interface. So both are going to work, and they're going to print the message. So considering the second example here, I have an interface welcome message and I have an abstract method in it. So this, even though I don't mention an annotation as at functional interface, this is a functional interface internally. So compiler, when it sees, it just identifies that as a functional interface because it's going to have an abstract method in it, or it is an interface with an abstract method. So in that case, if this functional interface is going to extend this method, what happens is this interface, functional interface example 4 is forced to provide, is forced to include this abstract method also in it, because the parent method also becomes a part of it. In that case, the concept that it should have only one abstract method gets disturbed. In that case, this functional interface doesn't act as a functional interface anymore since it has two abstract methods. To to avoid that, that is the main concept or the main feature of the functional interface is that it should have only one abstract method. But extending another functional interface changes its original behavior and causes and breaks the functionality that it has only one abstract method. So because of this case, the functional interface is not allowed to extend an interface which has abstract methods in it. So when we do the same, the compiler will throw an error saying it's an invalid functional interface because it does not include one abstract method. It has two here. So let's look at the examples here once. Hmm. So this is the first example. So I have a functional interface welcome it, and I'm just creating a class which implements a functional interface, and I'm just providing the implementation for the method. I'm just calling the method where it's going to print. So when we run this, so this is the message which we get. And going with the second example here. So here I have an interface, which is a functional interface, and I have an abstract method, and I have three object methods. As I already previously showed in the PowerPoint presentation, I have three object methods, which is a hash code, toString, and equals method. And here to provide an implementation of the abstract method, I'm just creating a class which is implementing the functional interface and providing a definition for the display method. I'm just calling the display method here. So again, this works fine. And going with the third example here. So here I have a interface, a normal interface which has a default method, and I have a functional interface which is going to extend that display interface, and I have an abstract method. So the second interface, which is the demo, is a functional interface, whereas the first one is a normal interface which just includes a default method. So when I try to extend or implement, that is, I have created a class which is going to implement demo. So in this case, I'm just providing an implementation for the abstract method of the demo functional interface, and I'm just calling the welcome method, and then followed by the default method of the parent interface. So here the functional interface is going to extend an interface which doesn't have an abstract method. So here it doesn't have an abstract method, so it should work fine because it has only the default method. Yes, so it works fine. And going with the fourth example here. So here you have an interface and you have a method, and this is an abstract method. So even if you don't explicitly declare that as a functional interface, it is also a functional interface here. And going on with the second interface, which is a functional interface, which is going to extend welcome message. Okay, so it has a method which is an abstract method. So here, if I, if so here it is the functional interface example 4.2. It contains only one abstract method, is not a functional interface because it extends one more interface which includes an abstract method. So by in turn, this includes two abstract methods. So when I forcefully make it, or when I forcefully make this class and mention that as functional interface to the compiler, it will throw an error to me saying invalid at functional interface annotation. Functional interface example 4 is not a functional interface. Whereas when I mark this as default, it works fine. But in the case of default, we need to create a body for this. So when it gets converted to a default method, then it works fine. So we don't need to worry about it. Okay. So this is how the functional interface works. Let's go into the next one, which is the default methods. So the second one is the Java default methods. So Java provides a functionality to create default methods inside the interface. So for now, we don't have any default methods inside the interface, but using the Java 8, you can create default methods inside the interface. So methods which are defined inside the interface and tagged with default are known as default methods. So as the sentence says, the methods inside the interface which are declared using the default keywords, those methods are called as the default methods. So these methods are non-abstract methods. So non-abstract method represents the default methods should have implementation as I showed you in the Eclipse example right now. So the concept of default method is used to define a method with default implementation. We can override the default method to more specific implementation for the method. So what does this say is the default methods inside the interface. So when you have default methods inside the interfaces, so those method definition represent some default behavior which are specific to that interface. So if you are extending or implementing that interface, so you can very well override the default method and provide your own definition for that default method. Or if you don't want to define that, or if you don't want to override it, you can use the existing default method available in the interface in your child classes or the child interfaces. So let's look at this example right now. So you have an interface welcome. So here you have the default method called the default void display. So as I rightly said, the default method should have its implementation here, and I just have a sysout statement here. And the second one is an abstract method where it doesn't have a method definition in it. It just has the method declaration, and you have a static method where it has the implementation part here also. So it's just going to it also just has a sysout message here. So a static method represents it has a class level scope. Since it's an interface here, it is an interface level scope where this method can be accessed directly using the interface name instead of creating the object. So we very well know it. So now, how could I implement this interface now? How could I use it? So just I created a class called default methods implementing this interface. So now, since I have a class which is implementing this interface, I need to provide a definition for the abstract method in it. So the abstract method here is the display more, and I have the definition for this display method here, display more method here. So it just takes the string as an argument, one string argument, and then it just prints the message whatever we are passing in. And then I'm just creating inside the main, I'm just creating an object for this class. I'm just calling the display method, which is the default method, which is going to print welcome to Bundle Hub channel as the first line, and that is what we get here. And secondly, I'm calling the abstract method, so where I have provided the definition in this class. So whatever the string we pass, that is going to get printed here. So For this display more, I'm just passing do, like, and shares, and this is what is going to get printed here as a second line. And the third one is calling the static method. Since I said the scope is at the interface level, we can access the static method directly using the interface name, and that's what I use, the welcome.display more. So I'm sorry, it could be display louder, display louder. So that is what it's going to print. Please do subscribe. Okay, let's look at the example here. Yeah. So here I have, so as a program which I've been showing the presentation, that's the same thing here. So we have the interface welcome, we have the default method, we have the abstract method here, and we have the static method display louder. So inside the class, I'm just providing the definition for the abstract method, and then I'm calling the default method here, I'm calling the abstract method here, and we're calling the static method, which is the display louder. So just let's run this and see how it works. Yeah. So this is what we get that we saw in the presentation. Okay, and let's move on to the last one. That's a Lambda expression. So Java Lambda expressions. So Lambda expression is used to provide the implementation of an interface which has functional interface. So what does this mean is this Lambda expressions help us. So these lambda expressions help us in providing functional programming by enabling functional programming in Java 8. So these expressions basically what do they do is they help us to provide implementation for the abstract methods of this functional interfaces. So to provide an implementation for the abstract method in a functional interface, so now what you're doing is you're just creating a class. See, what did we do here? So you're creating a class, implementing that interface, and you are overriding the abstract method of that interface, and then you are creating an object for this class and you're calling the method and using this. So you are going to create a class, and you're going to override that method, and you're going to create your object and then call it. So instead of all these things, lambda expression helps us to provide the definition for that abstract method in a single line, even without creating a class. So how does that help? So in this manner, what does it do is it saves a lot of code. You don't need to create a class. You don't need to override the method. You don't need to create an object. So in case of lambda expression, we don't need to define the method again for providing the implementation. So as I already said, you don't need to override the same signature of that method in an additional class, and you don't need to provide the whole syntax. That is, you don't need to have a whole method declared as such to provide the implementation. So Java Lambda expression is treated as a function, so compiler does not create a class file. So it is treated only as a function and not as a class. So the single statement or the expression that we write to provide the implementation for that abstract method, it is considered as a function but not as a class. So the syntax of the lambda expression will be like the parameter, the arrow token of the lambda expression, followed by the expression body. So parameter represents the input parameters. That is the argument list, which can be empty or non-empty. It represents you can have a method with input arguments and you can have a method with no input arguments. Anything is going to work, but the left-hand side of the arrow token represents the method arguments or the method parameters, and the right side of the token represents the expression body. That is uh, nothing but expressions or a set of statements which form the definition or the logic of that abstract method of the functional interface. So you have an abstract method in a functional interface, and you have to provide a definition for that. So you need to write some code in that method. So that block of code is is nothing but the expression body of the lambda expressions. So when we look at here, the syntax can be like no parameter syntax, one parameter syntax, and two parameter syntax. So no parameter syntax represents you don't have input parameters or input arguments, but you just have only the logic or the expression body to be executed. And the second case is like you have only one parameter, which you can mention here. That is the P1. So when you look at this expression here at the parameter inside the parenthesis, you are just mentioning the variable name, but you're not mentioning the data type. So P1 is just a variable of single argument. That is, you're just telling to that lambda expression that you'll be getting only one single input parameter, only one single input as a parameter. but we don't know the data type that it is going to send. We don't have any such details. You don't need even to mention that. It's optional. You can just say if it's going to be an integer, you can say int p1 or integer p1. It's up to you. Even if you don't mention it, the compiler is going to get it resolved at the runtime when you give the arguments to it, when you pass the parameters to it. So two parameter syntax is nothing but P1 and P2. It represents, you have two parameters. They represent the variable that P1 is one parameter and the P2 is other parameter which is going to take as an input here. So some of the important characteristics of a lambda expression are optional type declaration. So as I already mentioned, you don't need to specify the type of input parameter. It's fine if you just have that parameter variable name and optional parenthesis around the parameter. No need to declare a single parameter in parenthesis. For multiple parameters, parentheses are required. And optional curly braces and optional return keyword. So here, when you look at this expression where it represents the body, right, we are giving the curly braces. So if this body expression, that is the expression body, or if the logic is going to contain only one statement, in that case, we don't need to give this curly braces. You can directly enter the single statement here. And the curly braces is up to you that it is optional if you want to use it or not. If you have single statement, you can avoid it. If you have more than one statement, then curly braces are very important for it. And in the case of return, that is, for example, you have an abstract method which you want that method to return something. You want that method to return a value after processing it. In that case, you can have a return statement added to the expression body. And when you have a return statement, even if it is a single line, it's only the return statement that you're going to have. We need to have the parenthesis. When you have a written statement in your expression body, it's mandatory that you have the curly parenthesis. Even if that's going to be a single line in the expression body, still you need that parenthesis. So Lambda expressions are used primarily to define inline implementations of a functional interface, that is an interface with a single method only. So these Lambda expressions are basically used to provide implementation for the abstract methods of the functional interfaces only. You cannot use these Lambda expressions for the other interfaces which are not functional interfaces. Okay. So Lambda expression eliminates the need of anonymous class and gives you a very simple yet powerful functional programming capability to Java. So what does it say is, in order to provide the implementation for the abstract methods of an interface, how can you give it? You can't provide the implementation directly in a interface. You have to give that in the class which implements that interface. So you are forced to create a class to provide the implementation so that that abstract method implementation can be used by creating objects of that class. But using this lambda expressions, now you don't have an option, or the overhead of creating the class to provide definition or to use that functional interface is minimized, or even that is taken off, that is reduced. So let's look at this below example here for the lambda expression. So here we have a class called lambda example. So we have a main method, and we're just going to create an object for this class. And when you look at here, we have a functional interface which is called a math operation, and you have a abstract method in it called the operation, and you have another functional interface called the greeting service, which has a display method which takes the string argument as a parameter. So here I'm just creating an object for the functional interface called the math operation. And what I'm doing here is I'm just mentioning the input parameters and the arrow token followed by the body expression. So this body expression represents the definition for this operation function. See, instead of creating a class and implementing this interface and then overriding this abstract method, I'm directly creating an object for this functional interface, and I'm just assigning or providing a method declaration directly in a single statement as an expression using the lambda expressions. So this is the lambda expression which provides a definition for this abstract method in the functional interface. So as I said previously, this lambda expressions can be used only for the functional interface, because when I use the lambda expression, so this expression gets mapped to a single abstract method that is available in a functional interface. So if you have two abstract methods, then we don't know to which abstract method is that this expression going to map. It's very tough for us, right? So that is the case why the lambda expressions work only with functional interface, because they have only one abstract method defined, that is declared in them. So here I'm creating an object for the functional interface. So it takes two input parameters. Here I have mentioned the data type, but it's up to us whether we can mention the data type or not. And it is going to add it. And I have another object created for the same functional interface. It takes two input parameters, and I haven't mentioned any data type here. And I have the body expression here, which is going to subtract the values. And the other object which creates or which returns an output. So here I just have a single statement, but still I have used the curly braces because I have a return statement in this. So if you have a return keyword inside the body expression, then it is mandatory for us to use this curly braces. So here also it takes two input parameters and it is going to return the product of these two numbers as a result. So without using the return statement, I just have two input parameters which is going to return the division value of these two variables. Okay, so I have a private method here called the operate, which is going to take integer parameters, and the math operation, that is the math operation object, which is the functional interface object. So based on the object that I pass. So for example, here I'm passing operate of 10, 5, and addition. So here I'm passing the addition object of the functional interface. So what does that do is it just calls the operation method of this addition functional interface object. So this addition dot operation, what it does is it does the code of a plus b. This is the expression that gets called when you just invoke addition dot operation of this object. So similarly, when we call the subtraction, it evaluates this expression. When we call the multiplication, it evaluates this one. And when we call this division, it evaluates this expression. So now when we have a string parameter, so without parenthesis, that is I'm just using an input parameter without the parenthesis, since it has a single input parameter. So if you have a single input parameter, then it's not mandatory for us to use the parenthesis. So we have the token symbol, and here I'm just printing the message. Since it's a single line, I'm not using the curly braces here. So whatever the parameter value that we pass, it just prints appending it to hello. So here I invoke the display method of the first object where I pass everyone. So it appends with hello and just prints hello everyone. And in the second one, when I where do I have the parenthesis in the input parameters, I'm just printing it again in the same manner as the first one. And here it prints welcome to Pandul Hub, as I pass the Pandul Hub as a string to the display method of the greet service to object. So this is how. So when you see that previously we were creating a class and creating and implementing the interface and then overriding it and all those things. So all those many lines are just reduced and are removed, and we are able to do everything in just single line. So this is how the lambda expressions help us to uh, to provide a definition or to help us in functional programming. So what is the scope? What is the scope of lambda expressions? So using lambda expressions, we can refer to any final variable or effectively final variable. So what is that any final variable? So I'll explain that using an example for you guys. So what is a lambda expression? So what does this say is a lambda expression throws a compilation error if a variable is assigned a value the second time. So if you're trying to assign a value a second time, it is going to throw a compilation error. So what does this exactly say? Maybe instead of the sentences, maybe you'll be able to understand it clearly when we look at the example, an example for program. So let's consider this program. So I have a class called lambda scope. So here I have a final string, static string, whose value is hello, and I have a main method. And here I have a functional interface which has a abstract method called say message. So it takes an string parameter as an input, and here I have the definition of this abstract method using the lambda function. So here the input parameter is message, and I have the arrow token, and I have the body expression, so which is just going to print the message appending it to the final static string which I have declared here. So the output will be like, hello, welcome to Pandul Hub channel. So when you consider an example, I said I'll show you an example of the scope. So this is an example of a functional interface, I think which we have already seen. Yeah, lambda example. So here we have the example of the lambda expression. So this was the one which we saw in the presentation. So we have the main method, we have the class. I've created an object for that class, and we are creating multiple objects: addition, subtraction, multiplication, division for the functional interface. And then we are creating two more objects for one more functional interface, which takes the string as a parameter, and we are just calling them. So this was the same which I showed you in the presentation. And when you run this, you get the same output as I showed you in the presentation. So going with the scope, I think this is the one where you need to understand. See, so I have a class here. So I have a class, and before that, I have an interface, a functional interface, which just has one abstract method, which just takes string as a parameter. So here I have created a class. See, I have a class, and I have a final static variable, string variable, whose value is hello, and I have an instance value. So instance value represents, it is an instance variable of this class. So I have assigned the value instance variable to it, and I have a static variable. So the first one is the final variable, and here is a static value, which is a static variable. So I have given static value. And in the main method, I'm just creating an object for this class, and I'm creating a local variable inside the class, inside the main method. So I just created a variable inside the function. So it is specific. The scope is specific only to the function, which represents it's a local variable. So this local value is a local variable, so whose value I mentioned to be local variable. So now, so this is nothing but the lambda expression for the functional interface greeting service. So since I have more than one statement, I have mentioned it in the curly braces. So here I have created an object for the functional interface. I have the input parameter, which is a string, followed by the arrow token, and then the body expression. So inside the body expression, so I have a sysout statement which just prints a final value. So what does it print is hello, appended by the message that we pass. So that will be the first sysout statement for us. The next one is the instance variable. So instance variable, object scope dot instance variable. So instance variable can be accessed only using class object. So I'm going to create an object for this class, and using that I'm going to call the instance variable, which is the instance value, which just prints the instance variable for us. And next is the local variable. So local variable is inside the method, so we can call it directly. So here I'm printing the value of the local variable, and this is the static variable. Okay, so static value, I'm directly printing it. So let's see what does this print for us. Yeah, so here I have displayed all the four values as I already mentioned. Now let's say I'm just trying to edit the final value. So when I try to edit the final value, which is the final variable, the compiler is throwing me error that I cannot assign a value to a final variable. So final variable once declared is a constant, and you cannot reassign the value to it. So it's understood it in any case. So let's consider the instance variable. So I'm just trying to edit the instance variable value inside the lambda expression, body expression. So whether this will change the instance variable value, let's check. Yes, it changed. So the final value it's going to print, and the instance variable value has been changed. So its value change implies we were able to modify the value of the instance variable inside the lambda expressions. So when I try to change the static value, static variable value, let's see what happens. Yes, even I'm able to change the static variable value inside the lambda expression. So the last one, when we try to change the local variable, see, it is throwing some error for us. See, local variable, local value defined in an enclosing scope must be final or effectively final. Must be final or effectively final implies we cannot change the local variable value inside the lambda expression body. But why is that? But why do we cannot change it? Right? That is important, right? Why we are not able to change it? That is important, right? See, when we have a local variable, right? So the local variable implies it is specific to this block of code or function. Whereas when you consider the final variable, it is global. It is a constant value, it's a final thing. And if it's static, it has a class level scope. If an instance variable, you're accessing it using object. Whereas a local value, so if let's consider if there are two threads which are accessing this block of code or a method, in that case, each thread is going to have a different copy of a local variable. They don't have the persistence is not maintained. The persistency is not maintained between them, and then the values will not be consistent across two threads. So in that case, there will be a problem. So that is where it says the variables that are being accessed inside the lambda expressions must be final or effectively final. Okay. Uh, Hope it was helpful for you guys. And thank you for watching this video. Please do like, share, and subscribe. And do let me know if you have any comments. And do watch for the other parts for additional Java 8 features. And let me know if you have any queries. Thank you. Thank you so much.